Now we are going to draw vector field of this system of linear equations. Okay, let me just bring that here so that you can see the MATLAB command window. Okay, and what we are going to do is that we are going to follow the notes that I have posted from Dr. Budra for you. All right, so I'm just going to follow them strictly as they are. All right, so what we would do first is, so bring the command window of MATLAB, okay, and what we would do is this, that we are going to draw the vector field. So we will have to, draw a vector at each point x, y. So we are going to create a grid of values, all right, and here in this case we are proceeding with from 0 to 5 in the steps of 0.2. I'm just typing what he did. All right, so here we have a grid of values, and now what will happen is that at each point we will have vectors with these two components. So let's define the components here. Now we are going over mesh grid, so we would do this, that is we would use the dot command, not forget to use it, I meant, okay, don't forget this sign, otherwise it will give you a printout of the whole thing, and then minus y plus 0.9 times x, and then times y, and then okay, and now we will go ahead and take the length of the vector to divide by that, so that we have unit vectors there. All right, so attached at each point, so we got u square plus v dot square. All right, so and now we will just go and use quiver, and Dr. Budra used it in very clever way, that is, he didn't go with the snail space that I did. All right, going into the graph and looking at everything through the menu. First of all, he puts 0.5 over here. What it would do is that it will shrink the size of the vectors to half. All right, and then he puts this k in here because k stands for black in MATLAB. All right, and then he says x is equal tight. All right, so here we go. We have a good looking vector field here for this set of given differential equations. All right, okay, good. Now what we want to do is that we want to draw a phase portrait in here, that is some solution curves of the given system. And for that, what we would do is that we shall use ODE 45 for this system. So first we are going to ask it to hold on to the graph. All right. Now we have to do one thing, because we have already exhausted the notations x and y. So when we define an anonymous function for the phase portrait, what we will do is this, that or what Dr. Budra did was he decided to choose another notation for xy. X is denoted by p sub 1 and y by p sub 2, and let's call this vector as p. So again what we have is p1 is playing the role of x and p2 is playing the role of y. So let's go ahead and define an anonymous function. Okay, so here I'm writing tp, and p has two components. So to stress that, what I would do is this, that I shall put close brackets here, and for p I shall write these values. So I get 2 times p1, all right, and then minus 1.2 times p1 times p2, all right, and then we have the second component to be entered in this manner. So I have negative y, so that goes as negative p2 and then plus 0.9 times p1 times p2. Okay, and then I close the brackets and we are here then. All right. Now let us draw 4 curves passing through these initial points or satisfying these set of initial conditions. So what we would do is to denote 1.5 and then for the MATLAB command window, what we would do is that we will define 2 notations, A and B, okay, by writing the initial values of x for A and those of y's for B. Okay, so let's pull up our command window. All right, so what we have then is that we are taking A as 1, 1, 2, then 0.3, all right, and then B as 0.5, 1, 0.74, okay, and then we are going to do this. We are going to say for k from actually for k equals 1 through 4, here we are using k as an index, and then we shall say at t approximate solution, we are going to take it by ODE. So we have f, and for t let's stick to 0, 6. Again, you can determine it by intuition, inspection, or calculation. All right, and then we shall enter the values for the initial conditions. Okay, so bk, all right, and then we close this bracket. Sorry, I just have wrong bracket here. Okay, and so there we are. Okay, now we are going to ask it to plot. Now here I am indicating by this the first column, which is approximate values of A, okay, and then approximate solutions. You know, in the second column we have the approximate values for Y, okay, and let's just go with this smarter strategy, that is, instead of you know, going through the menu, we can just type it in command, and here we have, we'll just write for color, we'll write K right here for all of them, okay, and then we go here, and now we are just going to end the instructions, and let's see what we got. So we got, you know, a good, I mean, this phase portrait showing these 4 graphs, all right, these 4 curves satisfying those initial conditions plotted in the vector field, and you can label x and y as you saw in the instructions, and just go ahead and play with it. All right, let me know if you have any questions. Okay.